Okay, another one. I think this would be the hardest since I would be boarding my plane, or maybe I should check in already. So I think this would be a harder one since this is a stoichiometry. So may I read the problem: in alcohol fermentation, yeast converts glucose. So this one is your sugar and yeast is your microorganism to ethanol and carbon dioxide. So this is the chemical reaction of your yeast converting it into carbon dioxide. It usually happens in the stomach of the yeast. The stomach is yeast a what a but anyway, at the inside of the cell of the yeast. So given you have the of course the equation, you have to double check if it is already a balanced equation. So you have C6 and you have 2 carbon, here you have 4 and here you have 2. So basically it's 6. So usually the books gives you a balanced equation. That's as far as my experience is concerned. But since I will be giving you the quiz and exams, so mind you, I'm not that kind. So I might give you a unbalanced equation. So just be mindful that I'm not like those authors. Your sir is somewhat sadistic. I might give you an unbalanced equation, or maybe I will not. I might give you a unfinished chemical equation wherein you have to supply other things. Maybe I'll just put it in words and you have to supply it and then balance it. Okay. So you have a balance equation already that's given, and then you have a mass. Maybe we can write down our given. You have your mass. Mass, of course, that is given from the problem, 5.97 grams. So you have 5.97 grams. 5.97 grams. And then another one is volume, temperature, and pressure. Volume, temperature. Let's do it one by one. Volume would be lang. Mainit cancer memory, 1.44 liters. 1.44 liters. And then we have a pressure given to be 0.984 atm. 0.984 atm. Another one is Kelvin temperature. So that would be temperature at 293 Kelvin. Okay. So that's the given. So we analyze it first. We are given a 5.97 glucose, but our problem is carbon dioxide. So what is the percent yield of the reaction? So our carbon dioxide will be the problem. Why? Because it's the gas. Okay, this is gas loss. So we will be accounting from stoichiometry the gas. Okay, and you can see also the given is the carbon dioxide, which is a gas. So from this data here, you might get, or you should get, as far as I can analyze this problem, you should get a mass of your carbon dioxide, okay? Because the problem is percent yield, so you should be comparing the carbon dioxide from the actual carbon dioxide that was given from the problem, or stated from the problem, which should be we can compute from the ideal gas law, of course, because again, ideal gas law, because it is not stated that it would be real, so it should be an ideal, okay? And then you have a given of glucose 5.97 grams. From our previous topics, we can convert this glucose by stoichiometry into again carbon dioxide. So for the percent yield, we would just be dividing what is theoretically the actual carbon dioxide from the PV-nRT, and then divide it with the theoretical from the given 5.97 grams. That's how simple it is. Is it simple? Anyway, for me, because I'm already a sir and I've been solving a lot of problems, this would be an easy peasy for me. So percent yield would be, of course, from our previous topics, we know that percent yield is the actual of course, your theoretical is almost always bigger, because we usually have a chemical reaction which doesn't usually goes into completion. So basically, we're saying that your actual should always be smaller than your theoretical. Theory, okay? So actual, so this would be mass, actual mass, all over mass from theory or theoretically derived. Okay? Multiplied it by 100%, that would give you your percent yield. So, okay. Actual, I can put the 5.97 grams at the top, grams, and then your mass of the theoretical should be from your sorry, this one is the theoretical, the 5.97. We should be not convert, because that's already the mass. So that would be 5.97 grams. Okay, that is theoretical, and then the actual would be from the mass of the PV and RT. May we plug our equation for PV and RT? So we are given volume check, we are given pressure check, and we are given temperature check. We know the R, that's the gas constant, so we can compute the number of moles, N. So we know that we should be putting the mass, so therefore we can have again that equation for your number of moles equal to the mass all over your molar mass. So again, your molar mass, it should be computed from your when the compound is given, which is carbon dioxide. And I think we've already computed it. That is 44. The last time, that is 44. I think 44.09. So good thing is I still have my calculator, and the molar mass of the carbon dioxide is 44.009. So anyway, you have to double check it again, and if ever you have found any mistake that I did, maybe you can just tell me, and then you'll acquire a point for that. Of course, that's my ideals. Okay, so I'm not hesitating if ever I'll commit mistake, because I know you guys, you're good, and correcting me would be, of course, a good job to do. Okay, so that must be where are we? So you have your molar mass. So mass, so you can derive mass from this, which is PV over RT, and then multiplied by your molar mass, PVM over RT. So simple algebra will tell you that should be the case. So we will plug it for the actual. So that would be a PV molar mass all over RT, or maybe your RT would be, you can put it actually at the bottom. Okay, times 100%. As I told you, this is not as simple as it looks. So again, we can rearrange PVM all over the mass, which is 5.97 grams, and then we plug our RT, and then multiplied it by 100%. And finally, we substitute. So 0.984 ATM, and then you have our volume. We have our volume, which is 1.44 liters, and then the molar mass is 44.009. Unit would be gram per mole. And then all over, you have your 5.47 grams, and then your gas constant to be 0.082056 liter ATM per mole Kelvin. And then your temperature should be in Kelvin, and it is already in Kelvin. Oh my, di na magkasya yung board ko. 293 Kelvin. Since okay na naman siguro, I think hindi na tayo mag-expound. Of course, multiplied by your 100% for the percent yield. Okay, unit wise, cancel the ATM. You have liters, cancel the liters. What else? You have the gram per mole, you cancel the gram per mole. And then how about the Kelvin? The Kelvin, oh my, where? Here it is, 0.08 liter ATM per mole Kelvin. So here's the Kelvin, here's the Kelvin. So basically this part here has no units. Why? Because it's a percent yield. That is grams over grams. So we are now sure that maybe we're on the right track. Sure, and then maybe, oh my sir, what are you doing? You're sure and then you're saying maybe. I am sure, I'm just relating much to your case. Maybe you are not. 0.984 and then multiplied by 1.44 multiplied by 44.009 divided by 55.47 multiplied by 0.082056 multiplied by 293. Okay, and then multiplied overall by 100%, and that will give us a whopping 47.4%. In three significant figures, maybe, yes, as far as I can see, it should be in three significant figures, 47.4%. So I hope I didn't made any mistake, but if I did, just message me and I'll be giving points for that. Okay, thank you guys for listening. I think I should already check in my baggage. 11 minutes. So I told you this would be the harder one since it took me 11 minutes to solve it. Okay guys, God bless and thanks for listening. Ay, putlig.